Hey everybody, welcome back to this video number 3 in the Sequencing with Signals series. So this time we're talking about the stash object, which put very simply allows you to take a bunch of numbers, store them inside of the object, and play them back with signals. In the first video of this series we talked about phasor, which creates a clock, and in the second video we talked about subdiv, which basically allows you to kind of create events. Stash is the object that we use to actually tag those events with numbers, whether those are notes or velocities or some other parameter value. Stash is most of the time the object that I'm using to kind of create an actual sequence. It's a really powerful object. It can do actually a lot more than what I normally use it for. And I guess we could say that the way that it's used has two categories. So the first is really the sequencing kind of use case where we take a list that we're generating, maybe using a multi-slider or something like that. We pass that list into the object, and then we play that list back, usually driven by something like a subdiv object. The second use case is one in which, rather than using a list to store the values inside of it, we actually send a signal into it and send impulses into it as well that tell it when to basically grab samples of that input signal. In this way, it kind of works like a really, really powerful sample and hold. It's pretty awesome, at least in theory. I find myself not using it that way really ever. But we'll talk a little bit about that use case, and I'd be interested to hear from you all down in the comments below if you're using it that way. This object is very powerful. I think in part because of that, the help patch is a little bit confusing. So what I'm going to start by doing just off the bat here is talking kind of about the anatomy of the object, how the object is structured, and what that means about what it does. So let's get into that, and then we'll go into some examples. So the object has 4 inlets, 2 outlets. The first one is always the one that we're going to send the things that we want to store into. So whether that's a list or a signal, you're always going to pass that into the first inlet. The third inlet is the one that you're going to use to basically tell the object to return some of its stored values. And there's a bunch of different ways that you can actually do that, and we'll talk about that. So anytime you're using this object, you're pretty much always going to be using those first and third inlets. The second and fourth are active really only when you're doing that second use case, that kind of supercharged sample and hold use case, where the values that are coming into the object are signals. And the reason is that those inlets are used to kind of control when and where the incoming signal is saved. So if you imagine I have a noise signal, a bunch of random numbers coming into the first inlet. The second inlet is the one where if I send an impulse in, it says at this moment in time, grab whatever value you're currently receiving at the first inlet. The fourth inlet basically says where inside the stash object's kind of internal memory should it store that number. Because we can imagine the stash object as being almost like a shelf with a bunch of slots on it. In Max, we'd often use the word buffer to describe this, right? It's just a big, long container with a bunch of slots. If I pass in a list, it's going to create as many slots as there are items in the list, and it'll put each value in each slot. If I'm sending in a signal, though, it needs to know first how many slots are there, which I think by default is 1,000. And then anytime a new value is being stored, where should it be stored? And that's what this fourth inlet does. So we'll talk about more about kind of how that works a little bit at the end of the video. I will say that most of the time when I'm using this object, I'm passing a list in, and I'm kind of doing that first use case. On the outlet side, the first outlet basically is just going to produce whatever value you're asking it to return. And the second outlet is the position of that value in the internal buffer. Okay, so let's get into some actual examples here. So the first one here is the basic step sequencing example, and this is most of the time when I'm using this object, this is how I'm using it. You can see that it's here in yellow in the middle. And we have a multi-slider up here that's sending a list into the first inlet. And then we have a subdiv object that's producing from its second outlet a number that says basically what step it's on in its pattern. So if I get things running here, you can see we're getting these numbers from subdiv. And if you don't know what's going on here, definitely watch the other video. I'll put the link right up here. And in this mode, it's really working a lot like ZL lookup. If you've ever used this object, we send a list into the right inlet. And if I send a number, which has to be an integer, into the first inlet, it will output that value. In fact, if I get rid of this, and I just connect an integer box, I can kind of move through the list here. So stash in this mode is working exactly like that, except the first inlet is the one we send the list into, and the third inlet is the one that we send the value into. And then what we're doing is basically taking that value, which is being treated as a MIDI note, and we're sending it as MIDI out into live, where I have a drum rack set up. In a future video, we'll talk about how this MIDI stuff works with MC.MIDI player, which makes it really easy to convert these signals into MIDI. So in this example, we're using this kind of ZL lookup-like type functionality where we're sending a number, an index, into that third inlet. But there are other ways in which we can basically tell the stash object to output its contents. So let's talk about those. So in this example, we have 3 stash objects, and each of them has a different advanced mode. The one in the middle here is using mode 1, which is what we were using in the prior example in the previous tab. And then we have these others, 0 and 2. So these differ in terms of what the object is expecting to receive at its third inlet. In mode 1, like we saw, it's expecting to receive a number that is a slot, basically, an index. At mode 2, instead of an index, it's expecting just to receive a value between 0 and 1, and it will kind of internally figure out what slot that is. And then in mode 0, it actually, and this is the default mode, it just wants an impulse, and it will pick the slot on its own, basically. In its default mode, it's going to just, every time you send an impulse, it's just going to advance forward, one by one by one here. But there are also other modes that you can use, and for the kind of the way that it picks, and we'll talk about those in a second. There are also some other attributes for this mode 0 that allow you to define what constitutes an impulse. Here I'm using kind of the most classic impulse, just a subdiv into a what, so just a single sample pulse value at 1, and then otherwise it's always 0, which works great. If you had some other type of signal that was perhaps noisier or was just operated differently, perhaps you might use some of those attributes, which are called advanced level and advanced trigger mode, but I don't really find myself using them because I find that with objects like subdiv and what, it's pretty easy for me to produce very predictable impulses that will do exactly what I want them to do. So if I run this, we're not hearing anything, we're just getting the values. You can see that they're each producing values, and they're not actually producing the same values as they run along. And the reason is because when we actually get things working, these different modes end up having different results in terms of the values that they output. So let's kind of go through each of the examples. So for the middle one, starting with the index mode, the subdiv object is actually outputting a number that indicates which of these kind of LEDs, which of these steps that it's on. And you can see the pattern being represented down here. And because it sends that number from its second outlet, and that goes directly into the stash object, we get the value in the list that is kind of correlated to that particular node event. So on the first event, we always get 42. On the third one, we always get 46, and so on and so forth. With the first mode, or mode 0, it doesn't work that way. Every time we get an impulse, we just get the next value. So there's no kind of relationship between the values that we have stored in the stash and the actual pattern. And you might like that. That might be something that you want. It might not be. And so that particular detail is one way that you can kind of decide which of these two modes you're going to use. For mode 2 over here, we're actually not even producing any concept of this pattern. In fact, we just are getting a very simple ramp. We're just getting a kind of, regular output of these values that we see here in the multi-slider, because the subdiv object isn't in the signal chain. So we don't have this idea of a rest. We don't have this idea of like the 44 here getting skipped or whatever. It just all gets output. Now we could do something like, multiply the output of this by the output of the subdiv to kind of control and gate some certain events. So there's definitely ways that you can handle these things, but just off the bat, you can see that they kind of end up behaving differently, and you can use some of that, those differences to your advantage. So one other thing to keep in mind with these different modes is they kind of have different capabilities, and particularly with regard to two things. So the first is the direction. The mode 0 has this capability that allows us to, as I mentioned, change how it picks what slot it's grabbing from with a simple attribute. And so that's this direction attribute, which I'll show you in action. So in the default state, direction mode 0, we're going to get a very predictable result where every time I get an impulse, I just get the next value. And so you can see pretty clearly that in the scope here, we're getting the contents of this multi-slider. If I go to direction mode 1, I get those values in reverse. And if I go to random, I get them randomly. And if I go to earn, I get a unique random number. So I get them where it picks randomly, but it doesn't repeat a value until they've all been played. So pretty cool. You can get, like, for free, pretty much, really, really easily, these different directions. And if you saw the Metropolis video, or the like Max for Live Metropolis video that I did, one of the really exciting things about that particular sequencer is the ability to have these different directions by which the sequencer advances itself. And those are things that you can kind of build in yourself. And if you wanted modes other than these four, you would have to do that. But it's pretty awesome that this one just gives you a bunch of these really common ones for free. What mode 0 does not have, though, that modes 1 and 2 have, are interpolation. So interpolation basically means, in this context, say I have it in mode 1 where I'm sending indices. If I send it a value 2, it's going to give me the, if I send it 2, it's going to give me the value at slot 2. If I send it at 2.5, though, what does it give me? So that's the question that this interpolation parameter is answering. If I use interpolation mode 0, it treats 2.5 as if it were 2. If I use 1, it will treat 2.5 as a mix between the value that's stored at 2 and the value that's stored at 3. And finally, if I use mode 2, it will round to the nearest. So if I send 2.1, I'll get the value stored at 2. If I send 2.9, I'll get the value stored at 3. And we can see those in action here. So I have 4 stashes. The first 3 are all on index mode, so mode 1, and they each have different interpolation modes. And then you can see that on the first one, we're just getting this is the default, we're getting the stair-step pattern, so no matter what value I send into it, it's just going to round it down. And the values that I'm sending into the third inlet are derived from the subdiv, and it's actually the ramp output added to the step output. And the result that gives us is one smooth ramp that goes between 0 and 16. When we send that ramp into the third inlet of the stash object with this interp1, so linear set, you can see that we get this nice glide from one value to the next, with the exception of one jump. And this is where this interpolation feature has, I think, a little bit of an issue, which is that it can't interpolate from the last value to the first value. So in a second, I'm going to show you a way that we can actually fix that problem by building our own interpolation. Another thing to point out here is that in order for the interpolation to work, we have to pass those intermediate values in between one whole number and the next. If I take what's going into this third input and I just send the output of the second outlet of the subdiv object, we're not sending those intermediate values. We're just sending the whole numbers. So we get an output that it's identical to the first stash object here. Inter mode 2, round, as I've said, is rounding, and it's going to round to the nearest. So instead of always rounding down like mode 0 does, it will actually round up as well. And the result is very similar to mode 0, but basically, if I produce a signal like the one that I am here, where I'm going on a smooth ramp from 0 to 16, it's just going to get to each step a little bit earlier, half a step earlier. And then the final example here is linear interpolation mode, but the normalized ramp advanced mode. And this is just showing that the behavior is exactly the same between these two examples. So you can use either of those modes and achieve this interpolation. So let's talk for really quickly about how we can solve this problem with this jump, because in some, in this particular, like if I were using it for this particular situation where I kind of wanted to make this LFO type of thing, the jump kind of makes it less useful unless I really make sure that the first and last values are like perfectly lined up, which it looks like I've managed to do, but it's not ideal. So let's talk about that. So basically what we are going to do here is set up the stash in actually its default mode, so mode 0. And we're going to use the impulses to pick its value. And we're starting off with just the basic forward mode. So we have a what object here that produces those pulses that tells the stash object to output a new value. And anytime that pulse occurs, we do two things in a specific order. The first thing that we do is actually tell this saw object, or sample and hold, to store the value that the stash is currently outputting. Then, after that, one sample later, and you can see that it's one sample because we have this delay 1-1, which means that this impulse coming from the what object is going to be delayed by one sample. So one sample later, we tell the stash object, hey, give us a new value. The result of that we're going to get is the old value that we're interpolating from is going to be coming out of the saw object, the sample and hold, into the first inlet of this mix subpatcher. And the new value, the value that we're interpolating to, is going to come into the second inlet. And then we use the ramp from the subdiv object, first outlet, to glide from one to the next. And you can see that I have this example that you can actually hear where we're, modulating the frequency of a cycle. What's cool about this is we have total freedom to use any of the directions that we want to use. And that's because it's not interpolating by saying like, I know that we're going from 2 to 3 because 3 is 1 higher than 2. Instead, what we're doing is we're just taking the output of the stash object. Anytime we want to get a new value, we save what's currently being output, and then we get that new value, and then we slide from one to the other. So you could use this in a really generalized way. You can even use it with stash mode 1, where you're making, having some complex way of actually determining which slot you're selecting from, and have the interpolation completely work, which is really giving us the kind of all the power that we might ever hope to have with stash, of the ability to kind of use all the different directions and jump around the sequence in any way that we might want to, but also have the ability to glide between pitches or values or whatever those might be. Again, with the Metropolis video, the Max for Live device, the glide was one of the coolest things that that device can do. And this roughly is how that was achieved. Okay, so final example here, we're going to talk about the other way of using stash objects. So the situation where we're not sending in a list to store values inside of it, we're rather using a signal. And like I mentioned earlier, I haven't used this very much myself. I'm interested to hear what you all are doing, so I won't spend tons of time here, but we'll talk about it. So as I mentioned earlier, it's kind of like a supercharged sample and hold. And the reason that I say that is because sample and hold, which we saw in that previous example, it takes a signal into its first inlet, and the output will be derived from that inlet, and it will be whatever value was present at the first inlet when an impulse was received at the second inlet. So you can see that the result that we have here, where we have a subdiv going into a what that's producing an impulse, causes us to end up with this kind of stair-stepped quantized sine wave that's coming out of the cycle object. Stash is like a sample and hold, except it has more slots. So the saw object can only store one value at a time. The stash object has the ability for us to store many values, and then we can use that third inlet to say which value should be played back at any time. So a way that you could perhaps think of this is it's a bit like a tape machine, where we have both a read head and a write head, and we have complete flexibility to write to the tape and read from the tape at any point along the tape whenever we want to. So tons of power here. And this is where all four of the inlets can be in action. In this particular example, I'm only using the first three, and that's because the first one takes the cycle that we're sampling. The second one, as I mentioned at the top of the video, is taking an impulse that's telling that stash object when to sample. So working very similarly to the second inlet of the saw object. The third inlet is controlling the playback, and in this case, we're just using that normalized advanced mode and passing a phasor in. And the fourth inlet could be used to select where in the internal storage of the stash the sampled value should be stored. But we can also get the object to basically pick that for us by using this write mode 0, which is the default. So sort of like we have the advanced mode 0, where it will decide to read back from the slot given our direction attribute. In this write mode 0, it chooses to write to basically the next available slot. So it just kind of goes from beginning to end, looping around when it hits the end. If I choose one of these other two write modes, indexed or normalized index, I actually need to tell it by sending a signal into the fourth inlet where I want it to save things. If I select write mode 2 and then I patch the phasor in, now we're basically, every time the phasor loops, we have filled the full contents of the stash. So again, I can see kind of theoretically that there's a lot here that's very powerful, but I don't find this working its way into my own patching. I'm curious to see how you all are using it. Besides that, I have nothing else to talk about today. So happy patching. I'll see you next time. If you're enjoying these videos, please like and subscribe, and use the comments to tell me what you're finding with all of these. Are you liking these videos? Is there anything missing? Am I going too fast? Am I talking about too much? Are they too long? Love to hear that feedback. In the meantime, happy patching.